what problem are we on?
We are on 13-3, problem number 4.
Number 4 from 13.3A. Okay. So we need a figure that has an area of 2 and a perimeter of 4.2.
Yes.
Draw a diamond shape. Just my first thought. May not be right. But coming up with an area of 2 at the perimeter, 4√2. I'm thinking I need to have a hypotenuse.
I'm sorry, you're breaking up a little bit at the end there. I'm not sure I got what the last thing you said.
I think I did something with the hypotenuse. Instead of just a rectangle.
Okay.
Right. So if I have my geoboard and these are my dots all the way around it, I have an area of 2. I can tell that. So if I break it up like this, I have 4/4 of the square. So I put this little triangle with that little triangle, it gives me one square unit. And this gives me my second one. See how that's an area of 2.
What?
You see how I got my area of 2 there? I broke where I put some diagonals into my square.
Okay.
So just visualize this little triangle on top of the first triangle. That makes a unit square.
Okay.
And if you would just rotate triangle 3 and attach it to triangle 4, that gives you another little square. So I have an area of 2. Does that make sense?
Oh. Susan, do you see that? It is very difficult to visualize that, but I guess with the way that those arrows are up there, Susan, so she's just flipping that over to make 2 squares, right?
Yeah, and just rotating it, decomposing it and recomposing it. So it shows that we've got the 2 units. So that gets me an area of 2. Now the challenge is, do we have a perimeter of 4√2? So I'm going to put my dots of the geoboard back on it here so it's easier to see. Okay, so if I have 1 unit here.
Wait, can I go back to that area? Okay, so I see you have 2 square units. Okay, wait. Oh, so one has the area of 1, the other has the area, because it's 1 times 1. Area is length times width.
Well, what I did
is 1, the area of a second.
Here. So I'm taking this triangle and putting it together with this triangle. And when I rotate this one onto that one, that gives me 1 square unit.
Yeah, and then you add, okay, so this is 1 square unit plus 1 square unit.
Yeah. Okay, now I'm gonna pull this triangle out so we can just examine this one right here. So there's my geoboard. This is a length of 1. This is a length of 1. So what would this hypotenuse be right here?
Uh, 1 squared plus 1 squared equals x squared, right? 2 equals x squared. Okay,
So what does that give you?
well, so for the one triangle, it's the square root of 2. But that's if you use it as a variable, then you would have 1 square root of 2 plus 1 square root of 2 plus 1 square root of 2 plus 1 square root of 2, which is
How many square roots of 2 do you have?
4 square roots of 2.
4 square roots of 2, which is what you needed.
Susan, are you still
Yeah.
there?
I'm here.
All right, did you see that? It took me a minute to get it. I did not decompose those triangles at all, and that's what we had to do.
How would you, I mean, oh God. I don't even know how I'm supposed to know to do that.
What gave me the clue to do this was if you just had a rectangle, just a regular rectangle on your geoboard, then you would have had a whole number of units to add up to get your perimeter. Like if you had this one,
Mhm.
the perimeter would have just been 1, 2, 3, 4, 5, 6, and it would have been a whole number. So since it was a number times root 2, that made me think this might have to have a diagonal in it with a hypotenuse, requiring use of the Pythagorean theorem. So that's what gave me the clue to tilt my square instead of just having it in an orientation like this. Because on the geoboard in this orientation, we would have had whole numbers to work with for our units, for our lengths and widths. So it also helped that I've worked with geoboards. What you should do, what I would recommend, Susan, is at your school, ask if they have any geoboards. Just ask around to different teachers.
Okay.
Or go to a, just Google it. There might be a store near you where you can pick one up for cheap and play with
And
it.
I know that my library has some too, because they use them for lessons with the little guys. So even if your math teachers don't have them, the library may have
If
some.
you're at all close to Griffin, I have some in the math library at Southern Crescent Technical College. And you're welcome to check them out from there. Are you anywhere near Griffin, Susan?
No, I'm in Athens.
Oh, okay.
That is not near.
I'm sure that the University of Georgia would have some, I would expect anyway. Or a teacher supply store.
Yeah, I'll ask. I mean, all my sister-in-laws are teachers too, so I'll ask. They all teach different grades, so I'll ask them too if they've got one.
Yeah. It's pretty common that some teachers somewhere in the school will have a closet or a shelf.
So if we're on, can we just sail right through to number 5, just in the same mind thought of geoboards, because, and I don't know if I can figure it out with this knowledge coming in, but it's what is the greatest perimeter of any isosceles triangle on a 5x5 geoboard?
The greatest perimeter of any isosceles triangle on a 5x5 sheet.
All right, so I'm gonna try to make this make sense with what I've just been gifted by you. All right, Susan, let's get our teeth into this one, okay? Because I
This
still
one's
don't.
5x5. No, this one's only 4x4. Let me see if I can,
Okay.
blow
I
up.
wonder, I'm just thinking out loud, I wonder if this one is decomposed too into, because you can decompose that one into a square and 3 triangles. You see that, Susan? I mean, I may be completely off on this. The greatest perimeter of any isosceles triangle on a 5x5 geoboard. So it would, the top would go onto that middle dot, and then the bottom, it would come out to those last two. But you can make a square inside of there, and then 3 triangles. If we decompose that,
Here's my 5x5.
wait, hold on, the area of a, no, the perimeter. I just have area formulas here.
Use perimeter.
Do we have a perimeter formula for a triangle?
You have to get the distance all the way around your triangle. So on this one, you've got 5 for your length, 5 for your width. What if we drew a diagonal here? What if we put a rubber band there?
Wait, what?
Like if I put a rubber band all the way through the diagonal of that 5.
Well, I didn't do that. Would that make it an isosceles though?
Yeah, your length and your width are both 5, so it would be isosceles.
Well, snapdragons. Okay, yeah, nope, I didn't. Okay. Back to the drum. Okay, so I'm gonna go with a different color.
Then if
Okay,
you have 5 on the length and 5 on the width, use the Pythagorean theorem. What would be the length of your hypotenuse?
Susan, did you get what that hypotenuse was?
Sorry, I was muted.
Oh,
Oh,
so do 5 squared plus 5 squared equals c squared. What do you get for c? Are you working on that, Susan?
I'm trying to.
Okay.
No, I'm to the point where it's 50 equals c squared.
wait. Okay, see, I got it wrong too. I mean, because I thought it was, Okay, so did you get, I got 5 squared plus 5 squared equals c squared, right?
Yeah,
Right,
So that's 25 plus 25 equals c squared,
right.
which is take the square root. So it's c equals the square root of 50, which you decompose 50 into 25 times 2. So it's then 5 times the square root of 2.
uh-huh.
Okay, well, that's not what the book says. The book says the answer is 8 plus 4 times the square root of 2 units.
So along the vein of what we were just doing though, we found the hypotenuse was
Oh, we just found the hypotenuse.
5
Hold on,
root
I'm
2,
not done. Okay.
right?
The hypotenuse is 5 times the square root of 2, or 5 square root of 2.
And so to find the perimeter of that triangle, it would be 5 plus 5 plus 5 root 2. It would have been 10 plus 5 root 2.
Wait, so it's 5 square root 2 plus,
Plus 5 plus 5 if you're trying to find the perimeter of that triangle.
So where did they get the 8 from?
8 plus 4 square root 2.
Yeah.
And we got 10 plus 5 root 2. Ours is bigger than theirs.
So
I think we're right.
I think I'm right too. 10 plus 5 root 2
outside of Atlanta airport where we just wrapped up.
is bigger than 8 plus 4 root 2.
And my sister Andrea has
Yeah, I'm gonna go with that. So you won't count that wrong if we turned it in for her homework, right?
Oh, no, And if anybody watching this recording can prove me wrong, go for it. But let me just read the question one more time. And let's make sure. So this was, what is the greatest perimeter of any isosceles triangle on a
But
5 by
we're
5 geoboard?
we are definitely
And we're looking for 13.3A. Number 5.
yeah, yes, I can.
So yeah, their answer is 8 plus 4 root 2, but I know I have an isosceles triangle. I know I have 5 on the length, on the base and the height. I know my hypotenuse is 5 root 2 because this is a special 45, 45, 90 triangle where any side, if you take any side times root 2, it gives you your hypotenuse. So 5 plus 5 plus
That-
root 2 is
That works,
is
yeah.
5 root 2. So I'll mark that down on my notebook and we can ask the rest of the class if anybody got anything different, but I really think the answer on that one is bigger than 8 plus 4 root 2.
Well, and it makes sense. Susan, does that make sense to you?
Yes.
Oh, okay, yay. So we have 4, 5.
Okay, let me stop this recording.